Okay, from this assignment, what would you like to take a look at? What do you want to see? 98. All right, on 98, let's see, what do they have us doing? Find the indefinite integral. So we have the integral of the natural log of e to the 2x minus 1 dx. And then we remember that natural log and natural exponential functions are inverses. So the natural log of e to the 2x minus 1 is 2x minus 1. Oh, that's just not fair, is it? And then you take the integral of that. I know, you were wanting to do a bunch of work like on these. And you can, I guess. But there's no need to. What else would you like to see? All right, on 96. Did you try to figure out what u should equal? I did. Don't need a u. Okay? And I don't mind this division either. When the denominator is a single term instead of, a trinomial, binomial, then the division is pretty easy. So I just divided e to the 2x by e to the x, subtract the exponents, get e to the x. 2e to the x divided by e to the x. The e to the x is divided out, you get 2. And then 1 over e to the x, I wrote as e to the negative x. Then I can take the integral. And I did a substitution in this as well, but I did it in my head, which is always a little risky. Not just because it's my head, but in general. All right, so the integral of e to the x is, wahoo, e to the x. The integral of 2 is 2x. Now, I'm actually doing an e to the u, right? Because that's not just x. So u equals negative x, which means du equals negative dx, which means negative du equals dx. So when I would rewrite that, that would be the integral of e to the u negative du. So that's why that negative sign's there. Then the integral of e to the u is e to the u. So go ahead and put the x back in, e to the negative x. And, of course, don't forget your plus c. What else? To get rid of that negative exponent. Okay. Otherwise, I mean, don't if you don't have to, but we prefer to not have negative exponents if we can help it. Lindsay? 90? We okay with 99, everybody? All right, number 90. There it is. We're just finding the indefinite integral. So on 90, we've got several different things we can look for with the u, right? Quantities with exponents, quantities that are the denominator, and whatever the exponent on an e is. All those things, and that didn't even bring in the trig functions, but all those things are possibilities. So I settled on trying to let u equal that denominator, because and it wasn't a random guess, okay? But when you take the derivative of that, aren't you going to get that in it? So that's what I was hoping was going to go on, is that would help me get rid of or substitute for the e to the 2x dx as well. So let u equal 1 plus e to the 2x. Then take the derivative to get du, so that's 2e to the 2x dx. All right, which is awesome, except for the 2. So 1/2 du equals e to the 2x dx. And I'm in business here, okay? Here's how I made the substitution, all right? That is u. That is 1/2 du. And that's how I get the substitution. And once I get the substitution, I'm in really good shape. I can finish this one out. So I've got 1/2 times the integral of 1 over u du. We know that the integral of 1 over u du is the natural log of the absolute value of u plus c. Put the 1 plus e to the 2x back in for u. And you can stop on that line above where I stopped. But the natural log function is going, the e to the 2x is going to be positive. So then 1 plus that's going to be positive. So you don't have to have the absolute value signs anymore. Unless you are 100% certain you don't need them, just leave them on there. Don't take them away thinking, oh, I think I can take them away. No, leave them on there. Okay? So I'm good with that. All right, what else? 95. Ooh, that looks fun. All right, let's see. Wow, letting u equal e to the 2x doesn't really fit any of our things we normally try, does it? Okay? So, let me go through a few things here. Some thought processes. Let u equal 5 minus e to the x. Then du would be negative e to the x dx. Doesn't look real hopeful, does it? Okay, so then, well, maybe u equals 2x, because that happens sometimes, right? E to the u. What would du be? 2 dx. And I can do that. Still doesn't look all that hopeful, does it? Okay? So, I'm running out of options. It's not really a quantity that's my denominator, but I'm going to let u equal the denominator. All right, and let's see what happens there. So we let u equal e to the 2x. So then the derivative of e to the u is e to the u times the derivative of u. So the derivative of e to the 2x is e to the 2x times the derivative of 2x. So that's where the 2e to the 2x comes from, dx. And that doesn't look hopeful either. But stick with it. And okay, well, I don't have any of that in my problem up here, do I? None of it. So I will then multiply, or really I was thinking of dividing both sides by 2e to the 2x. So I'll multiply the left by 1 over 2e to the 2x. And the right, same thing. So I just have a plain old dx. And that's horrible, right? You're ready to give up, crumple your paper up, throw it in the trash, start over. But wait, that 2e to the 2x is 2u, isn't it? E to the 2x is u, so that 1 over 2e to the 2x is 1 over 2u. And we still might be wasting our time. I've gotten this far before making a substitution only to be completely stuck at that point. Haven't you? If you haven't been doing enough of the tough problems. Because it happens sometimes. You work 4 or 5 lines, and you're like, well, dead end. Okay, now, and I'm still feeling kind of like this might be a dead end. But also remember that I didn't even get started when I tried letting u equal other things. So I really want to stick with this one because I didn't think those other u's made any sense. Okay? Now, where did I get that from? If I've got u equals e to the 2x, that's u equals e to the x squared, isn't it? Because when you raise a power to a power, you multiply exponents. So if I gave you that, you would come up with that, right? So I'm working backwards here. And if that's the case, of both sides, I'd get the square root of u, and then the square root of something squared is the something. That gives me that. Now, why did I want that? Maybe I need to back up a step. Because from the looks on your faces, either you're completely disinterested or you're confused. Without doing that, let's try to make our substitution. Okay? 5 can stay 5. That's not a problem. E to the 2x in the bottom, that's u. dx, well, dx can be replaced with 1 over 2u du. So I've replaced all of that, and I'm still stuck with that. Okay? Let's come back and see if that would have worked, how well that would have worked out. Maybe. Okay? So, I got to replace that e to the x. So, as I just showed you, you figure out that e to the x is the same thing as the square root of u. And I'm still not sure I can take the integral of this. But at the very least, I've made my substitution. So I put the 1/2 out in front, and that's what I get when I make the substitution. Okay? Now, I've got a u in the denominator times a u in the denominator, so I can call that u squared for my denominator. And at this point, I'll do the division. So 5 divided by u squared is 5u to the negative 2. Negative, then the square root of u divided by u squared is u to the negative 3/2. And I think you can probably follow me from there. Power rule for both those terms. Write them without the negative exponents. Distributed the 1/2. Put the e to the 2x back in for u. Simplified the square root of e to the 2x as e to the x. Didn't bother trying to get a common denominator. And finished. All right, so let's see what would have happened if I'd have divided first. Because I ended up doing that, right? To get from this line to this line, what I did was divide the denominator into the numerator. So let's see how it would have worked to start off with. That'd give me the integral of 5e to the negative 2x minus e to the negative x. Is that right? Did I do the division right? So I can do, I could, then what I would want to do is either literally or at least think of it as separating these. For this one, I would need to let u equal negative 2x. du would equal negative 2 dx, then negative 1/2 du would equal dx. That'd be 5 times the integral of e to the u times negative 1/2 du. I can do that. Over here, I've already used the letter u, so I guess I'll use the letter, I don't know, r equal negative x. Dr would be negative dx. Negative dr would be dx. So that'd be the integral of e to the u. No, not u. E to the r negative dr. And then I got to bring that down. So let's see, what would I have? I'd have negative 5/2. Then the integral of e to the u is e to the u. Change that minus negative to a plus. And the integral of e to the r is e to the r plus c. So negative 5/2 e to the negative 2x plus e to the negative x plus c. Can I turn that into that? You betcha. So negative 5 over 2 e to the 2x plus 1 over e to the x plus c. Wow, a free other method. I didn't charge you a thing to show you that other one. I moved that factor to the denominator, so I changed the sign on the exponent. Hey, I kind of like that second version better. Wish I'd have thought of it. Yeah. Yeah, I'm not real fond of doing a u, breaking it in half and having a different u for each one. But yeah, I think the second method was better. All right. Others? Which one? 87. All righty. Still finding the indefinite integral. So I let u equal the square root of x. And kind of two reasons here, right? Make that an e to the u, and sometimes we let the denominator equal u, but really it was the first reason, e to the u. All right, so if u equals the square root of x, we have memorized, I hope, that the derivative of the square root of x is 1 over 2 square root of x. If you haven't memorized that, please do so. It's going to come up, I would guess, 300 times between now and the end of the year. Okay, only 250 times. But still, it's going to come up quite a bit, okay? And that's really close to what we have, right? We have a 1 over x, 1 over square root of x dx. So get rid of that nasty old 2. Multiply both sides by 2. And now, those things I have circled in red here and here are the same thing. We can do our substitution. So, in the numerator, e to the square root of x, that's e to the u now. And then our 1, because you always throw in a factor of 1, can't you? So our 1 over the square root of x with a dx can now be replaced with 2 du. Follow me? And if you do, then the rest of it's easy. Any others? Well, because the integral of e to the u du is e to the u plus c. Here's the way it works. The derivative of e to the x equals e to the x. Therefore, the integral of e to the x dx equals e to the x plus c. The derivative of e to the u equals e to the u, no, not u, the red. I'm grabbing the red. I'm obviously grabbing the red, not the stuff behind it. There we go. So I didn't want you there. So the derivative of e to the u, the derivative of e to the u equals e to the u times the derivative of u. Therefore, the integral of e to the u du equals e to the u plus c. So, in other words, we accounted for that chain rule part. Here. Right? All right. Anything else? 107. Yeah, it looks like I can. All right. So, on 107, they tell us to solve the differential equation. They give us dy dx equals x times e to the ax squared. That means we're going to have an a in our answer. It's a constant. Okay? I guess I don't know that I'm going to have an a in the answer, because if you take the derivative of a constant, it's 0. So I guess it's possible it's going to go away, but not real likely, is it? Okay? So if the derivative equals x e to the ax squared, then the function equals the antiderivative of x e to the ax squared. And then to get the proper notation, dx. All right, so let's treat this as an e to the u kind of integral. So let u equal ax squared. Then du will be the derivative of that. Remember, a is a constant. So constant multiple rule says the derivative will be a times whatever the derivative of x squared is, which is 2x. So instead of a 2x, I wrote 2ax dx. Well, we have just an x. But it's okay. Remember, a is a constant. So just multiply both sides by 1 over 2a, and we're ready to make our substitution. So look what we've got. We've got the integral of e to the ax squared. Since ax squared is u, that's e to the u. So I've taken care of all that. X dx, well, there it is. So that's 1 over 2a du. And I've made my substitution now. Okay? Well, like we just got through talking about, the integral of e to the u du is e to the u plus c. So leave your 1 over 2a in front. The integral of e to the u du is e to the u plus c. And then you can leave it like that, or you can write it as one fraction plus c. Now, quite often, they will give us initial conditions to get a particular solution. They didn't do that. So we have a general solution of the differential equation, and that's as far as we can go. They didn't give us any more information. How'd you do on 108? Yeah, I was stuck. So somebody yesterday, I think, we had an expression about like that, and what would happen if you square that? This would. I can take the integral of that. Okay. So sometimes you just got to put your head down and plow forward. Sometimes you got to back up and punt because it's a lot easier to play defense right now. How do I know when I need to put my head down and keep going like we did on, I don't know, the one that we did a minute ago? And how do I know when I need to back off and try something different? I don't. I've got to be willing to put the time in so that I can try whatever I got to try. Okay? Especially next year when you're in college. A lot of the people that you become friends with will not put the time in to get the correct solution no matter what it takes. You can't be like them. Okay? Those guys don't make A's. Okay? So, you know, when somebody tells you, yeah, I've got 30 minutes, I'm going to do my calculus. No, they're not. They're going to open the book, and then they're going to close it. That's about what you can get done in 30 minutes. Okay? So, especially next year, you know, have enough time that you can try the same problem several different ways. Now, on the other hand, don't get bogged down. You got 50 problems to do. Don't spend 3 hours on one. Okay, that doesn't make any sense either. But, you know, have some time, be able to try different ways, because you don't know what you're supposed to do. You don't know if you just need to suck it up and keep going, or you're just being silly because there's an easier way if you'll just think about it. Okay? Until you've worked hundreds of problems, you have no experience to even make a guess what you're supposed to do. So you guys will be ahead of the game there. You'll have worked hundreds of problems. Okay? All right. Let's wrap this thing up. All right, let's unwrap. So you take the integral of e to the 2x dx, let u equal 2x, so du equals 2 dx, but I don't have a 2, so 1/2 du equals dx. So when I rewrite this, that's the integral of e to the u, and then dx is 1/2 du, so that's 1/2 e to the u, then the plus c was at the end, so that's 1/2 e to the 2x, and that's what I put there. That one worked out the same way, just with a negative. Okay? So, yeah, I don't mean to do that and confuse you. Sometimes I get kind of like the solutions manual, but that's what I did. Make sense?